This is an algorithms question, actually based on Huffman coding. They have given us a string, this one, and each letter in the string has to be assigned a binary code satisfying the following properties. So using these two properties, we have to assign some encoding to the string and then determine among the set of all binary code assignments that will be given to that string. Satisfying these two properties, we have to determine what will be the length of this encoded string, which means for each character of the string we'll be assigning some binary code, and then what will be the length of that encoded string, that is what we need to answer. So let us have a look at what the two properties have been mentioned. For any two letters, the code assigned to the one letter must not be a prefix of the code assigned to the other letter. This is the property of Huffman code, and from this property itself we understand that they are talking about Huffman coding, because Huffman code is also called as the prefix code, and the code assigned to one letter does not become the prefix of code assigned to other letter. So from this we understand that Huffman coding has to be used. And the next property is saying that for any two letters of the same frequency, the letter which occurs earlier in the dictionary, which means if, let us say, in our example, B, C and D all are having same frequency. So when such collision happens, then the letter which occurs earlier in the dictionary, which means B in this case, the one which is alphabetically smaller. So what has to be done with it? It is assigned a code whose length is at most the length of the code assigned to the other letter, which means for the alphabetically smallest letter, what we have to do is the length of the code which will be assigned to that letter, that has to be at most, which means less than or equal to this one. It has to be less than or equal to length of code assigned to the others, which means the one which comes alphabetically first, that has to get a smaller length code. And when does this happen? When it lies on the upper levels of the tree, because leaf nodes will get the maximum length code, and those nodes which lie on the upper levels, let us consider this tree for example. Here let us say we have P, Q, R, S, T and U. So in this case, let us say this U and T, we are considering them. So what is the length of the encoding which this U will get? It will be 1, 2 and 3. It will get a 3 length code because it is at a distance of 3 from the root. But this node T lies on the upper level from U. Both are leaf nodes, but T is at the above level, so it will get only 2 length encoding. So from this BCD we'll have to place B over here and D at the bottom. So now, following all these properties, let us find out the encoding for this given string. Let us note down the frequencies of all the letters. For A it is 1, B, C and D it is 2, and for E the frequency is 3. So now we have to construct the Huffman tree for this string. So we will be starting with the one having least frequency, that is A. So let us construct A over here with frequency 1. Now this B, C and A all are having same. So what we will be taking first? At the bottom level D will come, and on the top levels B will come. So we will pick up D first and make it a neighbor of A. So this will be something like this. So now A is done, D is done. So we have B and C now, both of them will be taken at the same time. So we can have it like this, B and C both with frequency 2 taken over here. So now we are done with them. This E is left with a frequency of 3, so we can take it on the either sides of 3. Let us take it here, E with 3, then these 3 and 3 will make up 6. And finally this 6 and 4 will be combined to become length 10. So this is how encoding will work out. And now we have to find out for all A, B, C, D and E, what is the length of the encoded strings they have got. So we can go with 0 on the left and 1 on the right, or we can also go vice versa. We are not actually concerned with what encodings they are getting, we are concerned with the length of the encoding they have. So let us go with 0 1 notation. We can also go the other way around. So with this, A is over here. What is its encoding? It is 0 1 0. For D it is 0 1 1. Then coming to B, it is simply 1 1. For C it is 1 0, and for E it is 0 0. So we have got an encoding for all of them. Now, in order to find out the length of the total encoded string, what we'll do is we will multiply the length of these encodings with their frequency. So for A, the length of its encoding is 3, then 2 2 3 2. These are the lengths of their encodings, and now we will write down their frequency next to it. Frequency of A was 1, B, C and D was 2, and for E it was 3. So we'll just multiply them all and take the sum. So that will give us 3 4 4 6 and 6. And what is the sums up to? 3 and 4 7, plus 4 11, 11 and 12 is 23, which means the total length of this encoded string for the given string will be 23. So that is our answer.